Hello, dear listeners, and welcome to Sleepy Science Teller. Tonight, we'll travel beyond the stars into the quietest corners of existence, where silence itself begins to whisper. This is the story of zero-point energy, the background hum of the universe. When we imagine outer space, we often think of emptiness, a cold, silent void, but the truth is beautifully different, even in absolute stillness, even in the deepest dark. There's a faint vibration, a soft shimmer, a hidden energy that never fades. Scientists call it zero-point energy, the quiet heartbeat of reality itself. Before we begin, tell me, where in the world are you listening from tonight? And what time is it in your part of the universe? I always love to see where our little community of dreamers is tuning in from. Perhaps you're lying beneath a blanket. Perhaps you're gazing out a window. Wherever you are, I hope this story brings you calm. If you enjoy drifting through these bedtime discoveries, please tap the like button and gently subscribe. It helps our little universe of listeners continue to grow. Thank you, truly, out there, far beyond the glow of city lights, beyond the murmur of the earth's winds and oceans. There exists a quiet so deep that it feels eternal. If you could drift beyond the clouds, past the moon, and continue outward through the dark reaches of our solar system, you might imagine that sound itself has vanished. No whisper of air to carry a voice, no wind to move through the void, just a vast, endless stillness. Astronauts often describe it as the purest silence imaginable. When they gaze out their windows, orbiting high above the world, they can see the radiant blues of Earth below and the infinite black canvas stretching beyond. But if they were to step outside and listen, they'd hear nothing at all. The vacuum of space carries no sound waves. It is at first glance a universe asleep. And yet, this quiet is not what it seems. Beneath that stillness, beneath the calm darkness between the stars, there lies a hidden hum. A hum not carried by sound, but by existence itself. An energy subtle and eternal that moves through everything, everywhere, always. Physicists once believed that space was truly empty, a cold, vacant expanse separating planets, suns, and galaxies. They called it the void. But as human understanding deepened, as microscopes grew stronger and equations more refined, a new truth began to unfold. Even emptiness is not truly empty. The universe, it turns out, is never silent. Even when every atom is frozen, even when light itself fades into background, there remains a faint vibration, an infinite sea of invisible energy, gently humming beneath it all. This is the story of that hidden music, of the background hum, that threads through the cosmos and through us, the energy that never sleeps, the whisper between the stars, the gentle beginning of everything. Imagine yourself slowly drifting now, weightless, calm, surrounded by endless black velvet, streaked only by the soft glimmer of distant suns. Each star burns quietly, light years away. But between them, between all things, there is something invisible, something alive, something constant. If you could close your eyes there, in that perfect dark, you might feel it, a presence so faint, yet so everywhere, that it feels like the heartbeat of the universe itself. This is the realm of zero-point energy, the faintest tremor being the soft murmur of the cosmos' deepest silence. It is the beginning of every quantum story, the place where nothing becomes something, where stillness becomes motion, and where silence turns into a song. Let's drift a little deeper now, into this silence that is not silent. Scientists once wondered, if space was empty, then what fills the gaps between atoms? What lies between planets, between galaxies, between the stars? They found that the answer was not nothing, but a sea made not of water or light, but of energy itself. At first, it sounded impossible. How could something invisible, something immeasurable, exist everywhere? But when we study the tiniest scales of existence, smaller than atoms, smaller than quarks, we find a restless ocean, rippling with fluctuations, vibrations, and possibility. It is like the faint shimmer you see when sunlight dances upon a lake surface. From afar, the water looks calm, flat, perfectly still, but when you lean closer, you notice subtle ripples, tiny movements that never stop. The universe behaves the same way. On a cosmic scale, it seems silent, but on the quantum scale, everything is in motion, always. 0-point energy is that hidden motion, the smallest possible vibration that can still exist, even when everything else has cooled and calmed. Imagine a violin string. If you pluck it, it vibrates, creating a note. If you stop it, it becomes still. But in the quantum world, even when that string rests, it cannot be perfectly still. It must still quiver just slightly, for nature does not allow true silence. That faint quiver, that soft, unending murmur, is 0-point energy. Some physicists call it the music of creation, others the breath of the vacuum. Whatever name we give it, it remains one of the universe's most beautiful mysteries. Every particle, every atom, is floating on this invisible tide. Even you, lying quietly now, are surrounded by this cosmic hum. Every space between your molecules is filled with the same shimmering energy that fills the stars and the space beyond them. It connects everything, invisible but ever present. And perhaps when the night grows quiet and you listen deeply enough, you can almost sense it, not with your ears, but with your being, the faint awareness that all of existence is softly alive. Now, let's float even further outward, past the edge of thought, past the reach of light. Imagine drifting through the interstellar dark, where galaxies appear as distant islands, suspended in a vast black ocean. You're surrounded by emptiness, and yet you're surrounded by everything. The energy that moves through the space is ancient. It was there at the beginning of time, and it will remain long after the last stars have dimmed. Physicists believe that this background hum existed even before light. When the universe was only seconds old, a hot, dense, chaotic field, this energy pulsed at its core. As space expanded and matter formed, the hum remained. It never stopped. It's woven into the very structure of reality, the quantum fabric that underlies everything we know, from the birth of galaxies to the flicker of atoms in your breath. It connects all that ever was and all that will ever be. Some compare it to breathing. The universe inhales energy, then exhales creation. And even in the pause between breaths, the motion never ceases. 0-point energy is that eternal pause, that stillness that still moves, the breath that never ends. It's humbling, isn't it, to know that the quiet between stars is not truly empty, but full of unseen life, vibrating softly beyond our senses. And maybe That's the most comforting part. Even in the darkest corners of existence, there's always something moving, something alive, something gently reminding us that the universe never forgets how to breathe. So, the next time you look up at the stars and feel small, remember, you are not apart from that vastness. You are woven into it. You are part of that background hum. A single shining note, an eternal song of the cosmos. Close your eyes now and let that thought rest within you, like a calm tide upon the shore of your mind. Feel the stillness, and beneath it, the faint, endless hum. That is the gentle beginning, the quiet between stars, the soft foundation upon which all things rise. Imagine a quiet laboratory late at night. Lights are dim, instruments hum softly, and on a polished metal table sits a small sealed chamber. Inside that chamber is nothing. At least that's what it seems. No air, no dust, no particles. A vacuum so perfect that it could be mistaken for pure emptiness. But scientists know better, because even when all matter is removed, even when every trace of heat, light, and sound is gone, there remains something mysterious, something that refuses to vanish. That something is 0-point energy. It is the faintest, quietest form of motion that can exist, the leftover whisper of energy that remains. Even when everything else is stopped, to understand it, we must begin with a simple idea that the universe is made not of stillness, but of motion. Every atom, every particle vibrates, twists, shivers in an endless dance. And even when we cool those particles down to their lowest possible temperature, they cannot stop. They must still move ever so slightly, for nature never allows total silence. If they stop completely, the laws of physics themselves would unravel. So instead, they continue to hum softly at the faintest possible energy level, the 0 point. It's like the quietest note that an instrument can make, so soft you cannot hear it, but it still resonates through the strings of reality. This is not a sound we can hear, or a light we can see, but a vibration deep within the quantum field, the invisible stage where all particles perform their eternal play. To some scientists, 0 point energy is the foundation of everything, the energy of the vacuum, the hidden background that gives birth to matter, motion, and time itself. And to others, it's the hum that proves that nothing in nature is ever truly still. Even nothing, it turns out, is full of something eternal and quietly alive. Let's imagine for a moment that you could shrink yourself smaller and smaller until you were no larger than an atom, then smaller still, down to the level of electrons and quarks. The world would look entirely different there. Space would not seem empty, but alive, vibrant, constantly shifting. The nothing between particles would appear like a stormy sea, waves rising and falling faster than light could travel. Each crest of energy forming, fading, and reforming again. This is the quantum vacuum, the stage on which 0 point energy performs its endless dance. In classical physics, the kind of physics we use for planets, gravity, and cars, if you remove all energy from a system, it becomes still, completely quiet. But in quantum physics, that's impossible. The uncertainty principle tells us that we can never know a particle's exact position and speed at the same time. If it were perfectly still, we would know both, and that nature forbids. So even when a particle reaches its lowest possible energy level, it must still jitter, fluctuate, and hum ever so slightly. That faint motion, that soft restlessness, is 0 point energy. Now imagine the entire universe made of these trembling fields. Every atom, every photon, every grain of dust, floating in that restless sea. The background hum of existence itself. It's almost poetic to think that creation didn't emerge from absolute nothingness, but from an ocean of invisible energy, waiting patiently to give birth to light and matter. When the Big Bang occurred, it wasn't a spark in empty space. It was a ripple within this cosmic sea, the 0 point field awakening, expanding, unfolding into galaxies, atoms, and eventually us. So when you breathe in and exhale softly, know that even the air between your breaths is filled with this silent, infinite sea of motion. It holds galaxies together and cradles every molecule in its invisible waves. And even when everything seems still, that sea continues to move. Forever. 0 point energy. Sounds like a paradox, doesn't it? How can nothing have energy? How can emptiness be full? But that's the wonder of quantum reality, a place where opposites coexist and contradictions weave the very fabric of truth. Imagine an orchestra resting in the silence before a performance. The hall is quiet. The instruments are still, but in that stillness, there's potential. The violins could play, the drums could thunder, the flutes could sing, if only someone lifted the baton. That potential, that readiness to become something, is 0 point energy. It's not energy we can harness easily. It's not sitting there like a hidden battery, waiting to be tapped. Instead, it's the quiet potential of existence itself. Every field in the universe, the electromagnetic field, the gravitational field, the Higgs field, has a minimum energy, a baseline hum that never goes away. Even if all particles vanished, even if every atom disappeared, the fields themselves would still tremble softly, as if whispering, "I am still here." Scientists have tried to measure this faint energy and discovered something astonishing. If you add up all the quantum fluctuations in every part of space, the total energy density would be enormous. So enormous that if it were real in full strength, it would rip the universe apart instantly. And yet, here we are. The universe remains calm, stable, balanced, which means there's something deeply hidden, something we don't yet understand, about how this infinite energy and our reality coexist. Some believe it's the same force that drives the expansion of the cosmos, the mysterious dark energy that pushes galaxies away from each other. Others think it's a clue to new physics, to a universe far deeper and stranger than we can yet imagine. But no matter how we define it, 0 point energy remains the most beautiful reminder that there is no such thing as true nothingness. Even in silence, there is music. Even in emptiness, there is fullness. Even in stillness, there is motion. So the next time you close your eyes and feel the quiet settle around you, remember, you are not floating in emptiness. You are part of the soft hum that fills all space, from the smallest particle to the edges of the universe. And perhaps that gentle hum is the closest thing we'll ever find to hearing the voice of creation itself. If you step outside on a clear night and gaze up at the stars, you might feel surrounded by emptiness. Between the constellations, between the slow, ancient drift of the Milky Way, lies a blackness so vast, so endless, that it almost feels hollow. For most of human history, we looked upon that blackness and called it the void, the silent space between the lights, a cosmic desert, cold, still and utterly empty. But as we learn to look closer, as telescopes reached beyond our imagination, and microscopes plunged inward to the smallest scales of existence, we discovered that this darkness is anything but empty. Even the blackest, quietest patch of space is alive. The word vacuum, to most of us, means nothingness, but to physicists, it means something else entirely. It means a region where all matter has been removed. No atoms, no molecules, no air, and yet it still seethes with invisible energy. It is a stage alive with unseen motion, a restless sea of vibrations, bubbling and trembling at every point in space and time. When we say quantum vacuum, we don't mean stillness. We mean the most fundamental kind of activity there is, motion that never ends, even when everything else does. If you could somehow see it, the vacuum would shimmer, like sunlight glinting on the surface of the ocean, waves forming, collapsing, rising again, each ripple made not of water, but of pure energy. This is the world beneath the world, the soft hum beneath silence, the energy that exists before creation and remains long after. It's astonishing, isn't it, that what we once thought of as nothing is actually more full than we could ever imagine. Now let's drift closer, past the surface of atoms, past the swirling electrons and spinning protons, down into the emptiness between them. Even inside matter, there's far more empty space than solid substance. The heart of an atom is tiny, a dense, glowing nucleus, and around it, vast stretches of what seems like nothing. But that space is not quiet. It's a playground of possibility, a place where particles blink in and out of existence. Every fraction of a second, physicists call them virtual particles. They are not permanent, nor stable. They arise, borrow a tiny amount of energy from a vacuum, exist briefly, and then vanish again, returning what they borrowed as if nothing happened. But something has happened. Space has moved. Reality has trembled. The vacuum has shifted, just slightly, and in doing so, it proves that emptiness is alive. Imagine watching a pond. It looks perfectly still, but if you look closer, you'll notice tiny ripples, perhaps from insects landing or a soft breath of wind. The water's surface is always in motion, always adjusting. The quantum vacuum is the same. It may appear still from a distance, but beneath the surface, it churns with unending activity. Everywhere at every moment, particles are being born and erased. It's as if the universe is breathing in and out, particles and energy appearing, then dissolving back into silence. This constant movement is not a flaw or a glitch in nature. It's a feature, an essential part of how reality works. In fact, without these fluctuations, there would be no atoms, no light, no stars, no us. These fleeting bursts of virtual life hold the universe together. They affect how particles move, how forces behave, even how galaxies expand. Some scientists call this ceaseless activity the zero-point field, the lowest energy state possible, and yet never truly still. The vacuum is like a deep, invisible ocean. We float upon its surface, rarely noticing the waves beneath us. But those waves carry the patterns of creation itself. If you could peel away everything in the universe, every planet, every star, every grain of dust, even the light that travels between them, what would remain? Not nothing, but the quantum vacuum. This hidden field stretches through every corner of existence. It weaves through galaxies, seeps through atoms, and dances in the spaces between your own thoughts. It is not made of matter, but matter depends upon it. It is not made of time, but time flows through it. Every photon that has ever existed, every particle that will ever be born, rises from the sea of invisible energy. It is the blank canvas on which the entire cosmos is painted. To understand how essential it is, scientists have studied how even empty space can influence reality. When two metal plates are placed very close together in a vacuum, they are pushed together not by air or gravity, but by the invisible pressure of the vacuum itself. This gentle force is known as the Casimir effect, a soft nudge from the unseen sea. It's one of the clearest signs that the vacuum is not still, that space itself has a kind of pulse, and yet, as real as this energy is, we can barely grasp it. It cannot be bottled or easily used, for it balances itself perfectly. Every surge is matched by a fall, every creation balanced by destruction. The vacuum is the universe's way of holding stillness and motion in perfect harmony. It is the most delicate equilibrium imaginable, a field that hums with power, and yet remains calm. When you look at the night sky, what you see is not a void, but a fabric, a vast, invisible weave of energy, stretching infinitely in all directions. Every star, every galaxy is a luminous knot in that endless tapestry, and we, tiny beings on a small blue planet, are part of it too. The vacuum runs through you. Every atom in your body floats within it, vibrates because of it, and owes its existence to it. You are made not only of stardust, but of the quiet energy that fills the space between stars. So the next time you look into the darkness and feel small, remember this: the darkness is not empty. It is the most alive thing there is, a silent sea of infinite possibility, forever humming beneath the stillness. That hum is a quantum vacuum, not truly empty, but full of life, and softly, endlessly awake. There's a quiet rule that governs the smallest world, a rule whispered softly in the fabric of the universe. It was discovered in the early 20th century, when physicists began to peer into the realm of the very, very small, the strange, flickering world of atoms and light. One of these thinkers was a young German scientist, Werner Heisenberg. He was brilliant, thoughtful, and deeply curious about how nature behaves when no one is looking. He wondered, if we could observe a particle closely enough, could we ever know everything about it? Its position, its motion, its future? In the classical world, the world of falling apples, orbiting planets, and swinging pendulums, the answer seems simple. If you know where something is and how fast it's moving, you can predict where it will go. But as Heisenberg looked deeper into the shimmering, uncertain world of electrons, he found that this was no longer true. When scientists tried to measure exactly where an electron was, its momentum, how fast it was moving, became blurred, unsteady, as if the act of watching had disturbed its calm. And when they focused instead on how fast it was moving, Its location faded from clarity, like mist dissolving in morning light. The more precisely one property was known, the less precisely the other could be known. This strange balance, this fundamental limit to knowledge, became known as the uncertainty principle. Heisenberg realized that this was not a matter of bad instruments or clumsy experiments. It wasn't about what we could know, but about what reality is at the smallest scales. Nature itself refuses to be pinned down. An electron is not a point, but a wave of possibility. It does not have a definite position or speed. Until it interacts, until it's touched, seen, or measured, before that moment, it exists in a soft haze of probability, a cloud of maybes. Heisenberg's discovery changed everything. It told us that the universe, at its most fundamental level, is woven from uncertainty, not rigid, not mechanical, but fluid, alive, and full of mystery. And strangely enough, that uncertainty is not chaos. It is balance. It is harmony. It is nature's way of whispering. Some things are meant to remain unknowable. Imagine for a moment that you are trying to watch a single firefly. In the dark, you shine a tiny light to see it, but the light itself changes what you see. The firefly, startled, moves slightly, disturbed by your effort to look closer. This is what happens when we observe quantum particles. To see an electron, we must bounce light off it, but light carries energy. The moment we shine it, we disturb the electron's path. We can know where it was or how fast it was going, but never both at once, because our act of looking changes what is there. Heisenberg's principle doesn't just apply to electrons. It describes a fundamental truth of all matter and energy. Every particle, every photon, every atom has built-in uncertainty. It's as if the universe has drawn a thin, shimmering curtain between what is and what can be known. We can approach it. We can feel its presence. But we can never lift it entirely. The deeper scientists looked, the more they realized reality isn't made of solid, predictable objects, but of relationships, of interactions, of measurements that shape what we see. When we say that a particle has a position, we're not describing something fixed. We're describing a possibility. That becomes real only when observed. And this idea ripples outward far beyond physics. It tells us something profound about life itself. Every time we observe the world, every time we pay attention to something, we change it, and it changes us. Observation is not passive. It is creative. It is participatory. We are not standing outside the universe, watching from afar. We are part of its fabric. Our awareness, our curiosity, our act of seeing, all contribute to the dance of existence. So the next time you hear about uncertainty in physics, don't think of it as confusion or randomness. Think of it as a cosmic invitation, a reminder that every moment, every particle is alive with possibilities, waiting to unfold. The universe doesn't give us certainties. It gives us potential and lets us watch as that potential becomes real. It's natural to crave certainty. Our minds find peace in knowing what's next, in understanding why things are as they are. But in the quantum world, certainty is an illusion. Every particle hums between states, a blend of many possibilities, until something or someone collapses that uncertainty into one outcome. It's like a soft melody played by the universe, notes half-formed, drifting, shifting, waiting to be heard. Heisenberg's uncertainty principle teaches us to make peace with not knowing, to find beauty in what cannot be pinned down. It tells us that the fabric of reality is not static, but breathing, not certain, but endlessly creative. If everything were predictable, if every atom followed a perfect script, there would be no surprise, no spontaneity, no life. But uncertainty allows the universe to change. It allows stars to form, molecules to combine, and consciousness to rise. Without it, everything would be frozen, a lifeless mechanism, with no room for wonder. In uncertainty, there is freedom, there is motion, there is the gentle hum of creation itself. So when you look at the stars tonight and wonder what lies beyond, remember that they, too, are born from the same quantum haze. Each spark of light, each cosmic breath, emerging from uncertainty into being. The universe is not a finished thing. It is a question that answers itself, again and again, in the language of light and time and possibility. And perhaps that is its greatest beauty, that even in its smallest moments, the cosmos reminds us that to live, to love, to exist, is to dwell within the mystery. Not knowing is not a failure. It is a foundation of wonder. It is what keeps the universe awake. So close your eyes now and let that thought settle softly in your mind. The world is uncertain, and that is what makes it beautiful. If you were to sit very still right now, completely motionless, you might think that everything around you is at rest. The room seems silent, the air unmoving, the table before you steady and calm. But in truth, nothing is ever truly still. Every atom in your body, every particle of air that surrounds you is trembling softly, invisibly, in a ceaseless dance of motion. The surfaces that seem solid are built from atoms, and those atoms are mostly empty space, their electrons whirling at almost unimaginable speeds, their nuclei vibrating with faint, rhythmic energy. And even deeper than that, beneath the atoms themselves, there is a subtler movement, the soft flutter of subatomic energy that never fully fades away. This delicate motion is what scientists call zero-point motion, the irreducible vibration that remains. Even at the lowest possible temperature, absolute zero, at that limit where all thermal energy should vanish, the universe refuses to go completely quiet. There is always a hum, a shimmer, a restless sigh in the fabric of reality. It is the echo of quantum uncertainty itself, the physical embodiment of Heisenberg's principle. Even when nothing should move, particles still jitter, because if they didn't, we would know their position and energy too precisely, and that would break the rules of quantum mechanics. So instead, the universe maintains a gentle tension, a balance between knowing and unknowing, stillness and motion. You might imagine this as the soft vibration of the cosmic fabric itself, an eternal lullaby woven into every inch of space. It is as though reality is breathing, even in its sleep. These tiny tremors are unimaginably small, billions of times smaller than the motion of air molecules, far below the reach of ordinary senses. Yet they are everywhere. Everywhere there is space, there is movement. Everywhere there is energy, there is fluctuation. Nothing truly rests. The quietest silence you can imagine still carries the faintest murmur of the quantum world beneath it. So, the next time you sit quietly and feel the calm of stillness settling in, Know that beneath that calm, there is life, not noise or chaos, but a soft, rhythmic vibration, the subatomic flutter of existence itself. And somehow, that endless whisper of motion is what allows everything else to be. When scientists peer deep into matter, into the tiniest structures of a universe, they find something extraordinary. Every particle, every speck of matter is not just a point or a lump of stuff. It is a vibration, a wave, a note in a cosmic symphony that plays through time and space. This is one of the most beautiful ideas in physics, that the universe itself is a kind of music, and everything we see or touch is part of that melody. Electrons, protons, neutrons, all of them hum with frequencies, their behavior determined not just by mass or charge, but by how they oscillate within the quantum field. If you could somehow hear the vibration of an atom, you would be listening to a tone far beyond the range of human hearing, so high, so subtle, that it would make even light seem slow. And all those tones together form the structure of reality, like an orchestra of invisible instruments playing beneath the surface of things. When two atoms bond, it's as if their vibrations fall into harmony. When heat passes through a material, it's the flow of those tiny oscillations, rippling from one atom to another. Even the color of an object, the light it reflects or absorbs, is determined by the specific vibrations of the particles within it. So, when you see the blue of the sky, the green of a leaf, or the glow of a candle flame, you're seeing vibration made visible. You are witnessing the music of the quantum world, translated into light. And beneath it all, there's that soft hum, the zero-point energy, that keeps even the coldest vacuum trembling with life. Scientists once imagined that absolute zero, 0 degrees Kelvin, would be the end of motion, a frozen stillness where atoms simply stop. But when they cooled matter closer and closer to that limit, they found the atoms still moved, just a little, as if unwilling to let go completely. That tiny motion isn't just an oddity, it's essential. It prevents the universe from collapsing into perfect silence. It ensures that space itself remains alive, vibrating gently, ready to burst into new creation at any moment. You can think of it as the background heartbeat of the cosmos, a soundless rhythm that keeps everything connected, everything awake. We don't hear it with our ears, but perhaps, on some deeper level, our very being responds to it, because we are made from it. Now imagine this, the entire universe, from the tiniest atom to the largest galaxy, is made from a vast ocean of quantum fields. These fields ripple constantly, even when they appear calm. And those ripples, those subatomic flutters, are what we experience as matter and energy. The chair beneath you, the stars in the night sky, the light from your screen, all of it is born from those tiny, persistent tremors. Everywhere, the vacuum of space seethes with fluctuations. Particles appear and vanish in less than a heartbeat, borrowing energy from the field and then giving it back. This is not imagination. It is measurable. Physicists have built experiments that confirm the effects of these vibrations, like the Casimir effect, where two metal plates placed very close together feel a faint attraction caused by quantum fluctuations in the space between them. It's as if even nothing pushes back. These flutters may seem tiny, too small to matter, but without them, atoms would not behave as they do, chemistry would collapse, and the universe itself might not exist in its present form. It is humbling to think that everything we know and love is built on this constant, unending movement at the smallest possible scale. This is the universe's quiet secret. Motion never ceases. Stillness is an illusion, and from that invisible dance, all form, all energy, all life emerges. If you close your eyes now and imagine the dark between the stars, cold, silent, empty, know that even there, beneath the stillness, the flutter continues. Each vibration is a whisper, each fluctuation a breath, each tremor a tiny act of creation. It is the same flutter that once stirred the first particles into being, that shaped galaxies and lit the stars. And it is the same flutter that hums quietly within you, the rhythm of atoms, the pulse of life, the gentle vibration of existence itself. So, when you sit in the night and feel the calm of the universe around you, remember that even in perfect silence, there is motion. Even in stillness, there is song. And even in the emptiness of space, there is a flutter, soft, eternal, and full of wonder. Picture this: two perfectly smooth metal plates, resting just a few millionths of a meter apart, so close that even a single speck of dust would be too large to fit between them. Around these plates, there is nothing, no air, no light, no heat, a pure vacuum, emptied of all matter. It seems like nothing should happen there. After all, nothing should mean nothing. But in the quantum world, even emptiness is never truly empty. The space between those two metal plates is filled with an invisible dance, the same subatomic flutter we explored before. Tiny, flickering vibrations that never rest. These are the quantum fluctuations of the vacuum, and they carry energy even when no particles are present. Now here's where it becomes fascinating. Those vibrating quantum fields can exist in infinitely many frequencies, from the slowest ripples to the fastest tremors imaginable. But when we place two plates very close together, we quietly interfere with that cosmic orchestra. Between the plates, only certain wavelengths of vibration can fit, those that perfectly match the distance between the plates, like the standing waves on a string. Outside the plates, however, there are no restrictions. All wavelengths are free to exist. This creates an imbalance. Outside the plates, there is more quantum vibration, more energy, more pressure. Inside, there is slightly less. And because nature loves balance, the plates are gently pushed together by the difference in energy between the inside and the outside. That force, so faint, so delicate, yet so real, is called the Casimir effect. It was first predicted in 1948 by Dutch physicist Hendrik Casimir, who realized that even empty space is filled with potential energy, and that this energy could, under the right conditions, reveal itself as a measurable force. At first, it sounded like a fantasy, a theoretical whisper in the equations of quantum field theory. But decades later, scientists built experiments sensitive enough to measure it, and there it was, a tiny pull between two metal plates, arising from the vacuum itself. No electricity, no magnetism, no physical contact, just the quiet pressure of quantum energy, gently nudging the plates together. It was the first time humanity had caught a glimpse of the vacuum's hidden heartbeat. To truly understand how small the Casimir effect is, imagine placing two metal plates, only a few nanometers apart. That's a billionth of a meter. At that distance, the force pulling them together is only a few millinewtons, about the same as the weight of a tiny grain of sand. Yet to physicists, it's monumental because it proves something profound, that nothingness is not truly nothing. Even when we remove all matter, all heat, and all light, the fabric of space itself still shivers with energy. That background hum, the quantum field's restlessness, is enough to create a real, measurable effect in our tangible world. It's as if the vacuum is alive, breathing softly, moving subtly, whispering through the tiniest of forces. The Casimir effect is more than just a curiosity. It's a reminder that the universe hides its deepest truths in the smallest corners. In laboratories, scientists have learned to measure this force with exquisite precision, using micro-machine devices, ultra-polished mirrors, and instruments that can detect displacements smaller than an atom's width. When those plates drift together, driven only by the pressure of empty space, it's like watching the invisible hand of the cosmos make itself known, quietly, gracefully, without a sound. And this subtle interaction isn't just a scientific wonder. It also has practical consequences. In the world of nanotechnology, where machines are built smaller than dust particles, the Casimir force can cause components to stick together unexpectedly. Tiny gears, switches, or beams that are designed to move freely sometimes fuse because of this gentle vacuum pressure. Engineers now design around it, accounting for the invisible pull of the quantum field, just as they would account for gravity or magnetism. It's humbling to realize that something so faint can become so significant when you shrink down far enough. The closer we look, the more we discover that emptiness itself is full of surprises. There's a beautiful way to imagine the Casimir effect as two tiny boats floating on a restless ocean. From above, the water might seem still, but beneath the surface, waves are constantly rising and falling, colliding and canceling, creating patterns of quiet motion. Now imagine those two boats floating close together. Between them, the waves cannot form freely. They are restricted, squeezed, but outside, the full rhythm of the sea continues, pressing in with greater strength. Slowly, gently, the boats drift toward one another. This is what happens with the Casimir plates. The vacuum is the sea. Its waves are the fluctuations of quantum fields. And the plates are boats, drawn together by the sea's invisible energy. This simple image captures a profound truth. Even space, the emptiest place we can imagine, is a sea of motion. Everywhere, energy rises and falls in invisible ripples. And once in a while, those ripples touch our world in a way we can measure. It's a reminder that the boundary between something and nothing is not sharp at all. It's soft, like a horizon seen through mist. Casimir's discovery whispers of a universe that never truly rests. Even when we remove everything we can see or touch, there remains a pulse, a vibration woven into the fabric of reality. Some physicists even suggest that this zero-point energy might be connected to the mysterious force we call dark energy, the power driving the accelerated expansion of the cosmos. If so, then that tiny pull between metal plates is not just a laboratory curiosity. It's a small echo of the same vast force that moves galaxies apart. From the tiniest scales to the largest, the same hum continues. Steady, patient, eternal. The Casimir effect is the first doorway through which we glimpse it, a real-world window into the hidden energy of existence. So next time you hear the word vacuum, don't imagine emptiness. Imagine a sea, soft, shimmering, forever alive, between every atom, between every breath. That sea moves gently, holding the universe together. And somewhere in that infinite quiet, two tiny plates still float, drifting closer, carried by the whisper of the quantum ocean. If you close your eyes and imagine the blackness of deep space, you might think of a calm, silent emptiness stretching endlessly in all directions. But in the language of quantum physics, there is no true stillness. Even the emptiest space is alive with tiny, imperceptible fluctuations, subtle changes in energy that appear and disappear spontaneously. These are called vacuum fluctuations. A vacuum might seem empty to our senses. No air, no light, no sound. But at the quantum level, energy never rests. The vacuum hums with tiny waves of activity, a constant, restless dance beneath the apparent stillness. These fluctuations arise because of one of the universe's most fundamental principles, that energy cannot ever be perfectly zero. Even when a system reaches its lowest possible energy state, there remains residual motion, a soft trembling of existence itself. This trembling is not random chaos. It follows the rules of quantum mechanics, governed by probabilities and subtle balances. The vacuum is a sea of potential, filled with the faintest ripples, and each ripple has the power to create something extraordinary. Within this restless void, virtual particles appear. They are called virtual because they exist only briefly, flashing into reality for a tiny fraction of a second and then vanishing back into the sea of energy. Even though they exist for only an instant, their effects are real. They can influence forces, bend light slightly, and even create measurable phenomena, such as the subtle Casimir effect we explored earlier. The vacuum, then, is not nothing. It is a bubbling, shimmering expanse of energy that quietly shapes the universe. Even in what seems like perfect stillness, the cosmos is alive with subtle, ceaseless motion. To imagine virtual particles, think of sparks flickering along the surface of a fire, tiny bursts of energy appearing briefly before fading back into the darkness. These particles come in pairs, a particle and its antiparticle, mirrored twins born from a vacuum itself. They exist just long enough to leave an imprint on reality, and then disappear, returning their borrowed energy to the quantum field. Though invisible to the naked eye, their presence is undeniable. They affect how atoms behave, how light travels, and even how forces between matter arise. The virtual particles are a reminder that the universe is participatory. It is not a silent stage where events passively unfold. It is a dynamic, breathing entity where even empty space contributes to the story. Physicists have found evidence of virtual particles in subtle ways. For instance, they influence the energy levels of electrons in atoms, and they can slightly alter the behavior of light passing near strong fields. Every moment, in every corner of space, these tiny bursts of creation and annihilation occur, quietly, invisibly, endlessly. They are the heartbeat of the vacuum, the soft pulse beneath the cosmic stillness. reminding us that emptiness is never truly empty. Even more fascinating, these virtual particles may have played a role in the birth of the universe itself. In the moments after the Big Bang, quantum fluctuations could have seeded the first structures, tiny variations in energy that eventually grew into galaxies, stars, and planets. So when you gaze at the night sky and marvel at the vast stretches of dark space, remember this. Even there, where we perceive nothing, the universe was quietly dancing, tiny virtual sparks flickering and shaping the cosmos itself. The dance of virtual particles gives a vacuum a texture, a subtle complexity that challenges our very notions of empty. It's a gentle reminder that reality is not static. Space itself is alive with possibility, a shimmering fabric that hums beneath the surface of all that exists. Even as particles vanish as quickly as they appear, they leave traces, influences, and patterns. For example, virtual particles contribute to the vacuum polarization effect, slightly altering how electric charges interact at very small scales. They are, in a way, the hidden threads holding the universe's tapestry together. This also points to the interconnectedness of everything. No particle exists in isolation. Every particle, every atom, every star, is subtly influenced by the unseen sea of virtual particles surrounding it. Some scientists have speculated that if we could harness even a fraction of this vacuum energy, it could become an inexhaustible source of power. Though, for now, this remains a dream, a whisper of possibility, within the unyielding laws of physics. But whether harnessed or not, the significance of virtual particles is profound. They reveal that the universe is not a lifeless void, but a restless, humming entity, teeming with motion at every scale. Next time you sit quietly or gaze at the empty sky above, try to imagine the tiny flares of virtual particles flickering into existence and vanishing like fireflies in the infinite darkness. They are the invisible fabric of reality, the subtle currents beneath the calm surface of space. They remind us that the cosmos is alive, even where we perceive nothing. And in that soft, ceaseless dance, we can sense the quiet miracle of existence itself. Imagine a place colder than the coldest winter, colder than the heart of deep space, a place where all motion seems to vanish, where even the tiniest particle of heat has been removed. Physicists call this ultimate temperature absolute zero, 0 degrees Kelvin or minus 273.15 degrees Celsius. It is the point where, theoretically, all classical motion of atoms should cease. No vibrations, no collisions, no jostling of molecules. Yet, even here, the universe refuses to be perfectly still. At this edge of cold, we encounter zero-point energy, the subtle, inevitable energy that remains, even when everything else is frozen. Atoms, electrons, and particles still jitter slightly, as if the universe itself insists on movement, even when it seems that nothing could move. This trembling is not disorder. It is natural. It is a delicate balance between the laws of physics and the infinite possibilities embedded in the quantum world. Even in perfect stillness, there is life, a soft, invisible heartbeat of the cosmos. Scientists have observed this by cooling substances to near absolute zero, using lasers and magnetic traps, and discovering that no matter how cold the material becomes, atoms never fully stop. They continue to oscillate, reminiscent of a faint whisper, the universe's way of saying, "Even here I am awake." This gentle persistence of motion is what defines zero-point energy. It is a reminder that nothing is ever truly nothing, that emptiness and stillness are illusions, and that even at the coldest extreme, the quantum world hums softly, endlessly. To imagine zero-point energy, think of a frozen lake under a pale winter sky. On the surface, it is smooth, glassy, and silent, but beneath the ice, small currents flow, tiny movements ripple, and the water, though hidden, is never completely still. The atoms and particles at absolute zero behave similarly. Even when cooled to this ultimate limit, they vibrate. This is not heat. It is something more subtle, more fundamental, a fluctuation that persists because of the rules of quantum mechanics. It is directly tied to the Heisenberg uncertainty principle, the idea that one cannot know both a particle's position and momentum with perfect precision. If an atom were truly motionless, its position and energy would be known exactly, which is forbidden by the universe. So, even at absolute zero, atoms keep moving slightly, a soft jitter that ensures the laws of nature remain intact. Physicists have created Bose-Einstein condensates, materials cooled to billionths of a degree above absolute zero, and have watched atoms merge into a single quantum state. Even in this extreme stillness, the zero-point energy remains a gentle hum beneath the frozen calm. This subtle motion shapes reality in profound ways. It prevents atoms from collapsing into one another. It stabilizes matter, and it keeps the universe in its delicate balance. Zero-point energy at absolute zero is more than just a curious fact. It is the quiet, persistent hum that threads through all existence. Imagine lying beneath the night sky, feeling the cold, silent air around you. To the senses, all is still, but at the atomic level, there is movement, vibration, life, even in the vacuum of space, even in the coldest corners of the cosmos. Zero-point energy ensures that the universe never fully rests. This tiny, ceaseless jitter is a kind of cosmic lullaby, a gentle, invisible pulse that underpins reality itself. It reminds us that stillness is only a surface, and beneath it, the universe is awake, humming softly, alive with infinite possibilities. Zero-point energy is the foundation of everything: matter, light, forces, and perhaps even the subtle energies that bind galaxies together. It whispers of a universe that never truly sleeps, that vibrates quietly beneath the calm, and that carries within the potential for endless wonder. As you drift in your own quiet space tonight, you can imagine this soft, invisible hum surrounding you, flowing through the very atoms of your body and echoing in the spaces between stars. It is the gentle heartbeat of existence itself, ever-present, serene, and timeless. Imagine, for a moment, the universe as it was nearly 14 billion years ago, a hot, dense sea of energy and light, expanding and cooling in a delicate, silent rhythm. As it expanded, the intense light gradually stretched into longer, fainter wavelengths, until the searing fire creation cooled to a gentle, almost imperceptible glow. This is what we call the cosmic microwave background, the soft echo of the Big Bang itself, still present, still vibrating quietly across every corner of space. Though it is faint and invisible to our eyes, sensitive instruments can detect it everywhere, a uniform hum of microwaves, whispering the story of the universe's birth. And here is the remarkable connection. The background energy of the vacuum, the zero-point energy we've been exploring, is intimately linked to this cosmic glow. The vacuum is not an inert nothingness. It is alive with fluctuations, tiny ripples that hum even when the universe is empty. And the energy of the vacuum contributes to the subtle forces shaping the cosmos, including the evolution of the cosmic microwave background itself. In other words, the faint hum of empty space is not separate from the hum left over from the birth of everything. They are threads of the same vast tapestry, woven together through the fabric of space and time. Everywhere we look, the universe whispers of its earliest moments, from the void between stars to the faint glow across galaxies. The memory of creation is encoded in light, and in the subtle vibration of zero-point energy. The cosmic microwave background is like a photograph of the universe as a newborn, capturing the gentle energy that still lingers, echoing softly through space. A lullaby of beginnings, stretching across billions of years. If we could travel across the universe at the speed of thought, we would see that the vacuum is never truly empty. Even in the most desolate regions, energy fluctuates. Virtual particles flicker in and out of existence, and the very space between galaxies hums with life. The cosmic microwave background serves as a bridge between the quantum and the cosmic scales. It shows that the faint hum of the vacuum, the ceaseless jitter of subatomic particles, is not just a curiosity in laboratories. It resonates across the universe itself. Scientists have mapped this background in exquisite detail, finding tiny variations in its temperature that correspond to regions of slightly more or less energy in the early universe. These fluctuations seeded the formation of galaxies, stars, and planets, the structures that fill the universe today. And at the deepest level, these variations were influenced by the zero-point energy of the vacuum, the soft, restless energy present even in empty space, nudged the newborn universe, guiding the formation of matter and leaving subtle imprints that we can still observe billions of years later. In this way, the vacuum and the cosmic background are partners in a cosmic dance. The invisible energy beneath the surface of space connects to the faint glow of creation, linking the tiniest quantum flutters to the grandest cosmic structures. It is as if the universe hums in unison, from the smallest particles to the largest galaxies, a harmony of energy and light, stretching across the fabric of space-time. Even now, when we look at the sky, the faint glow of the cosmic microwave background surrounds us, a reminder of the soft whispers of energy that have persisted since the very beginning. Think of the universe as a vast, silent orchestra. Each particle, each ripple of the vacuum, each photon of the cosmic microwave background is a note in this infinite symphony. The zero-point energy provides a subtle rhythm, the gentle pulse underlying every motion. The cosmic microwave background carries the melody, the lingering echo of creation's first song. Together, they form a lullaby that stretches across billions of years and light years of space. It is soft, almost imperceptible, yet it is the foundation of everything: matter, stars, galaxies, and even life itself. Even as we sit quietly on a small planet in a distant corner of the universe, we are immersed in this ancient hum. Every breath, every heartbeat, every flicker of thought occurs against the backdrop of this cosmic energy. The vacuum, the zero-point energy, and the cosmic microwave background remind us that the universe is never truly silent. Even in emptiness, there is movement. Even in stillness, there is life. Even in darkness, there's a gentle glow. As you lie quietly tonight, or watch the stars above, imagine the soft hum of the vacuum beneath you, the faint glow of the cosmic background around you, and the gentle rhythm of a universe that has been alive since the very beginning. It is a lullaby of energy, of time, of existence itself, a quiet, eternal reminder that even in vast emptiness, there is wonder There is motion, there is life, and in that soft hum, we are all connected to the heartbeat of the cosmos, to the gentle echo of creation, and to the infinite dance of energy that never sleeps. Imagine the vast stretches of space between stars and galaxies, vast, silent, and seemingly empty. To the human eye, it is nothing, darkness punctuated by distant pinpricks of light. Yet, even in this apparent nothingness, there exists a subtle energy, a faint, persistent presence that permeates every cubic centimeter of space. Physicists call this the energy density of the vacuum, the intrinsic energy that resides in empty space itself. It is a profound idea that empty space is not truly empty. It is alive with potential, humming softly with quantum fluctuations and zero-point energy. This energy is not visible, not tangible in the traditional sense, but its influence is everywhere. One way to imagine it is as a gentle pressure, uniform and unyielding, present throughout the cosmos. This energy density may be responsible for the accelerated expansion of the universe, the mysterious force we call dark energy. Even where there are no stars, no planets, and no particles, the vacuum itself pushes outward, shaping the destiny of galaxies and clusters across unimaginable distances. It is a quiet power, subtle yet immense. While we may live our lives unaware of it, this energy is the foundation upon which the universe evolves. It is a reminder that the concept of nothing is a human limitation. The universe does not adhere to our expectations of emptiness. In laboratories, physicists have observed the effects of this energy in small but measurable ways. Tiny forces arise in the vacuum, as seen in the Casimir effect. These phenomena hint at a vast reservoir of energy lying just beneath the surface of space, an invisible ocean that underlies every corner of reality. Even more intriguing is the sheer scale of this energy. The vacuum's energy density is astonishingly large if calculated theoretically. If it could be harnessed, even a minuscule volume could contain enormous amounts of power. Yet, nature keeps it hidden, subtle, and unobtrusive, a silent reservoir that shapes the cosmos without fanfare. Now imagine the universe as a balloon. Inside there is matter, stars, and galaxies, but the fabric of the balloon itself is the vacuum, and the energy within it acts like a gentle, invisible pressure. This pressure is uniform, stretching across space, and it can push the universe outward, influencing its expansion. Physicists discovered this connection when they observed that galaxies are moving away from one another and that this expansion is accelerating. Some invisible influence is at work, something that permeates the emptiness of space and exerts a subtle force. The energy density of the vacuum is a candidate for this mysterious influence. It is quiet, pervasive, and constant, the same yesterday, today, and billions of years ago. Unlike matter, it does not clump or collapse. It flows gently, evenly through the void, reshaping the cosmos in ways that are almost imperceptible. In a way, this energy is like a soft whisper to the universe, nudging galaxies and stretching space itself, without breaking the stillness we perceive in our daily lives. Even at the scale of individual atoms, this energy exerts influence. It contributes to forces between particles, to the fluctuations that keep atoms from collapsing, and to the very structure of matter itself. Thus, empty space is a reservoir of quiet power. It is everywhere and nowhere, silent yet forceful, invisible yet essential. It is a foundation upon which the universe's architecture rests. As we drift in the night, gazing at the stars or lying in quiet solitude, We are immersed in this subtle energy. The vacuum's energy density is not just a concept for physicists. It is part of our lived experience. Even if we cannot sense it directly, every movement of galaxies, every pulse of light, every particle in our bodies exists within this energetic background. It is a gentle reminder that we live not in empty space, but in a dynamic, vibrating continuum that hums with life. Some scientists speculate that if we could learn to harness this energy, it might offer unimaginable possibilities, a nearly infinite source of power. For now, though, it remains a quiet, cosmic presence, unseen, unfelt, yet shaping the universe at every scale. When we imagine the vast emptiness of the cosmos, we can think of it not as nothing, but as a sea of subtle energy, a quiet ocean beneath the stars, restless yet serene, containing potential to shape galaxies, stars, and the very evolution of the universe itself. And in this awareness, we can feel connected to the universe's deepest rhythm. We are not separate from the cosmos, but immersed in its quiet energy, floating in a gentle, invisible tide that hums softly. Through the fabric of reality, the universe is alive in its silence, and we, too, are part of that silent symphony. Imagine looking up at the night sky, a vast, dark canvas sprinkled with stars, galaxies, and distant clusters of light. For centuries, humanity assumed that gravity was the dominant cosmic force, holding galaxies together, shaping stars, and controlling the motions of the cosmos. But in the late 20th century, scientists made a startling discovery. The universe is not only expanding, it is expanding faster and faster. Something unseen, something mysterious, is pushing galaxies apart, accelerating the expansion of space itself. This enigmatic influence has been named dark energy, a force or energy that fills the void, yet remains invisible, intangible, and largely unknown. Dark energy is puzzling in every sense. Unlike gravity, it does not attract. Unlike matter, it does not clump. It is uniform, pervasive, and seems to dominate the universe, making up approximately 68% of all cosmic energy. One of the most intriguing ideas in modern physics is that dark energy might be a distant cousin of zero-point energy. The faint hum of the quantum vacuum, the restless energy present even in empty space, could be connected to the mysterious force driving the universe's expansion. Imagine the vacuum of space as a gentle, invisible ocean. Its subtle pressure nudges the fabric of the cosmos, and on the grandest scales, it is powerful enough to stretch galaxies apart. We cannot see it, we cannot touch it, but its presence is undeniable in the motions of distant stars and clusters. In this way, dark energy is like a silent, cosmic sibling to the tiny, restless energy that exists between atoms. Both are hidden, subtle, yet both shape the universe in ways we are only beginning to understand. To grasp the essence of dark energy, imagine the universe as a vast balloon. Galaxies are like tiny dots on its surface. Gravity tries to pull them together, drawing them closer over cosmic time. But the balloon is also expanding. Something within the fabric of space pushes outward, stretching distances, pulling galaxies apart, and accelerating as time goes on. That something is dark energy, a silent, persistent pressure embedded in the vacuum itself. Interestingly, the mathematics of general relativity allows for this kind of energy. Einstein's equations predicted that space could have an intrinsic energy, a property that causes it to expand or contract independently of matter. The connection to zero-point energy arises here. If empty space is never truly empty, if it hums with quantum fluctuations and subtle vibrations, then perhaps this restless energy is what manifests as dark energy on the cosmic scale. In other words, the gentle, ceaseless jitter of atoms and fields in the vacuum may have a grand cosmic echo, pushing the universe to grow ever larger. Some scientists even describe dark energy as the weightless heartbeat of the cosmos, an invisible rhythm that ensures the universe continues its expansion quietly, without interruption. Unseen but profoundly felt, dark energy is mysterious, yes, but it is also beautiful in its subtlety. It reminds us that the universe is not only matter and motion, but also the soft energy between, the quiet force that shapes existence without announcing itself. As we ponder dark energy, we realize how little we truly know about the cosmos. We can measure its effects. We can observe galaxies accelerating away from one another. We can calculate the rate of expansion and the influence on cosmic structures. Yet we do not know what it is in conventional sense. It is a ghostly, pervasive presence, like a soft wind blowing across the universe, felt but invisible. And perhaps that is part of its magic. It connects the smallest scales to the largest, linking the restless hum of the quantum vacuum to the grand expansion of galaxies. It is a reminder that the universe is more than what we see, more than matter, energy, and light. Dark energy invites us to wonder, to imagine, to explore the hidden threads that shape reality. It whispers that there is still much to discover, that even in the void there is a pulse, a rhythm, a cosmic heartbeat. So when you look at the night sky tonight, remember that the space between stars is not empty. It is filled with energy, subtle and unseen, a mysterious force pushing the universe outward, and a gentle reminder that the cosmos is alive, even in its quietest corners. And in that gentle hum, we sense the connection between the tiniest vibrations of particles and the largest stretches of space, between zero-point energy and dark energy, between the invisible threads of existence and the vast, expanding universe. It is a cosmic lullaby, soft and eternal, reminding us that even mystery can be beautiful, and that the universe never truly sleeps. Imagine floating above the cosmos, beyond stars, beyond galaxies, beyond even the faint glow of the cosmic microwave background. At first glance, the universe seems smooth, as the space itself is calm and continuous. We imagine straight lines connecting stars, planets orbiting in orderly patterns, and distances measured in predictable ways. But according to quantum physics, space at its tiniest scales is not smooth at all. It is frothy, restless, alive with subtle fluctuations. Physicists call this quantum foam, the idea that space-time itself has a texture, like the surface of a gently bubbling sea, at scales far smaller than atoms. This foam is invisible to our eyes and even most instruments, but its presence is suggested by the very principles of quantum mechanics. If energy can never be perfectly zero, then space itself must jitter, ripple, and fluctuate. Even empty space-time is restless. Imagine a pond on a quiet morning. To the eye, it seems perfectly still. But zoom in down to the tiniest scale, and you see ripples, tiny bubbles and minute disturbances, ever-changing and ephemeral. This is what space-time may look like at the Planck scale. A texture of tiny fluctuations and ceaseless motion. The quantum foam is a foundation reality. It is a subtle, invisible scaffolding upon which matter, energy, and light are built. Every particle, every field, every force emerges from this restless sea. Even the vast distances between galaxies exist atop this intricate, frothy substrate. To explore quantum foam, think of space-time not as a smooth canvas, but as a dynamic, living ocean at unimaginably small scales. Perhaps 1/1,000,000,000 of a trillionth of a trillionth of a meter, space is a seething froth of activity. Bubbles appear and vanish. Tiny distortions ripple through, and the very concept of distance and time becomes fluid. These fluctuations may give rise to the phenomena we observe as quantum mechanics. They may influence how particles emerge, interact, and decay. They may even underpin the mysterious zero-point energy we have been discussing, the soft hum that persists everywhere. Physicists imagine these fluctuations as a kind of microscopic storm, tiny tempests that bubble in and out of existence, shaping the foundation of the universe itself. And yet, despite the turbulence at the smallest scales, the universe appears smooth at larger scales. Galaxies form, stars shine, planets orbit, and life emerges, all atop the restless froth of space-time, a gentle reminder of the hidden complexity beneath what we perceive as calm. This quantum foam is the ultimate whisper of the cosmos. Even in a region of empty space, there is structure, activity, and energy, a subtle, eternal dance that forms the bedrock of reality. The beauty of quantum foam is that it connects everything. It links the tiny, restless world of particles with the vast scales of the cosmos. It hints at a universe where even emptiness has texture, where the very fabric of reality is alive, and where energy and motion never truly cease. If we could somehow see the universe at this scale, it might appear as a gently frothing sea, with peaks and valleys, bubbles and ripples, all vibrating softly in tune with the quantum hum. Every atom, every photon, every force we know arises from this intricate dance. Even light itself may follow the contours of this frothy texture, and the vast empty spaces between galaxies exist atop its restless surface. Quantum foam reminds us that what appears still is never truly still. What appears empty is never truly empty. The universe is alive in its quietest moments, its foundation teeming with hidden motion, its fabric vibrating in delicate, ceaseless rhythm. As you lie quietly tonight, or imagine the vastness of space above you, picture the universe as a gentle sea of foam, a soft, invisible texture beneath all we see. It is the hidden pulse of existence, the subtle stage upon which every star, planet, and particle performs. Even in darkness, even in silence, the foam hums softly, a lullaby of space-time itself, gently holding the cosmos together and carrying the universe forward, ever alive, ever awake. Imagine a world where energy is everywhere, flowing quietly through the fabric of space, never ending, never depleting. This is the vision behind zero-point energy, the faint, ceaseless hum of the quantum vacuum, the tiny vibrations and fluctuations present even in empty space. If we could somehow tap into this energy, it might provide a limitless source of power, a gentle, silent flow sufficient to light cities, propel vehicles, or power technologies beyond our imagination. Scientists and dreamers alike have long been captivated by this idea. Even the smallest hint that zero-point energy could be harnessed ignites visions of a world free from scarcity, where energy is abundant and quietly available, flowing like a river beneath the visible world. Yet there are profound challenges. This energy is not like electricity or heat. It is woven into the very fabric of space-time, present everywhere and nowhere Tiny, fleeting, and subtle. Attempting to extract it is like trying to scoop up the ocean. With a teaspoon, the energy exists, yet it resists capture. Even the most sophisticated experiments yield only whispers. Tiny, fleeting effects, barely perceptible against a background of the universe. And yet, the allure remains. Humanity has always dreamed of harnessing forces that are invisible and vast, from the wind to the tides, from the sun to the stars. Zero-point energy is the ultimate challenge, a silent, pervasive force, just out of reach but waiting like a gentle current beneath a calm sea. To understand why harnessing this energy is so difficult, imagine trying to catch the faint tremor of a hummingbird's wings. Amidst the roar of the ocean, zero-point energy is subtle, distributed uniformly across space, and intimately tied to the laws of quantum mechanics. It cannot be turned on or off, cannot be stored in batteries, cannot be channeled in the ways familiar to us. Furthermore, the energy is governed by the uncertainty principle. It is a restless motion, always fluctuating, never static, making it nearly impossible to extract without disturbing the system itself. Despite these challenges, scientists continue to explore tiny glimpses. Phenomena like the Casimir effect show that vacuum energy can exert measurable forces. These experiments hint at the possibility of future technologies, even if they remain decades or centuries away. It is also important to approach this idea with care. Extracting energy from a vacuum, if possible, would involve interacting with the very fabric of reality. The consequences are unknown, perhaps gentle and beneficial, or perhaps profound in ways we cannot yet imagine. For now, harnessing zero-point energy is a dream, a whisper of possibility in the quantum sea, a reminder of the boundless potential hidden in the universe. Even without harnessing it, zero-point energy is a source of awe. It reminds us that the universe is more than what we see. It is alive with subtle vibrations, a silent pulse beneath every atom, a quiet rhythm that persists through the vastest stretches of space. The dream of harnessing it inspires curiosity, creativity, and wonder. It encourages us to explore the hidden laws of nature, to listen to the soft hum of the vacuum, and to imagine what is possible when we respect the delicate balance of the cosmos. Perhaps one day, humanity will find a way to gently touch this energy, to use it wisely, without disturbing the harmony of the universe. Until then, it remains a silent companion, flowing beneath our feet, through the walls of our homes, and even through our bodies. Zero-point energy, the hum of the cosmos, is a reminder that even in emptiness, there is power, and even in stillness, there is motion. As you drift tonight, you can imagine this energy flowing quietly through space, through the atoms of your body, through the very vacuum around you. It is infinite, elusive, and serene, a gentle lullaby from the universe itself. Imagine a night sky, still and silent to our eyes. Stars sparkle gently, planets drift along their orbits, and galaxies stretch across the darkness. It may seem calm, almost frozen in time, but the universe is never truly at rest. At every scale, there is motion, vibration, and subtle energy, even in what appears to be perfect stillness. From the ceaseless jitter of atoms, to the invisible hum of zero-point energy, to the restless vacuum teeming with virtual particles, motion is everywhere. Galaxies drift apart, pulled and pushed by the hidden energies of the cosmos. Cosmic expansion continues silently, accelerated by dark energy, while gravitational forces weave their intricate tapestry, binding stars, planets, and clusters together. Even the vast voids between galaxies are not empty. They vibrate with the faint energy of the vacuum, holding subtle currents that ripple across space-time. The universe, at every level, is awake. It is never still, never silent. It hums, it vibrates, it flows, a cosmic symphony that continues through every instant, whether observed or not. To imagine the universe that never sleeps, think of an ocean at night. From a distance, it appears calm and smooth, but if you look closely, waves ripple across the surface, currents flow beneath, and every molecule moves in subtle, ceaseless ways. Similarly, the universe has layers of motion. The quantum foam bubbles at the smallest scales. Atoms and particles vibrate relentlessly, and galaxies drift, spin, and rotate across unimaginable distances. Energy flows through all of it. Zero-point energy hums beneath the surface. Dark energy gently stretches space itself. And light travels across billions of years, carrying information from the earliest moments of creation. Even the cosmic microwave background, the faint echo of the Big Bang, reminds us that the universe has been awake since the very beginning. No corner of space is completely still. The smallest scales are restless, and the largest scales are in motion. The universe never pauses. It is a living, breathing entity in which time flows, energy moves, and existence continues endlessly. In this way, we are participants in a vast, unceasing dance. Our own lives, our own motions, are small ripples in the greater symphony, intertwined with the motion of stars, galaxies, and the subtle energy of space itself. Even as the universe never sleeps, it does not roar with chaos. Its motion is gentle, graceful, and harmonious. The quantum vibrations, the cosmic expansion, the drift of galaxies, all follow the elegant laws of physics, a quiet order underlying apparent restlessness. Every atom in your body vibrates softly, mirroring the motion of the universe. Every breath you take, every heartbeat, is connected to the ceaseless rhythm of existence. The universe's constant activity is a comforting reminder. Even when we sleep, even when we feel still, the cosmos is alive, flowing, moving, humming softly beneath the surface of perception. This knowledge can bring a sense of peace. It is a lullaby on the grandest scale, a reminder that rest and motion coexist. That quiet stillness contains activity, and that existence is a gentle, eternal flow. As you settle into the calm of night, you can imagine the soft hum of galaxies, the vibration of atoms, the subtle currents of vacuum energy, all interwoven in a universe that never sleeps, yet carries you gently in its eternal rhythm. It is a reminder that even in darkness, even in silence, there is motion, energy, and life. The universe is awake, and we are part of its unending, serene dance. Close your eyes and imagine the vastness of space around you. A deep, dark expanse sprinkled with distant stars, nebulae, and galaxies. It appears silent to the human ear. Yet if you could listen with a cosmic awareness, you would hear the universe humming, a faint, eternal vibration underlying everything. This is the eternal hum, the soft, continuous resonance of zero-point energy, the restless motion of particles, the subtle vibrations of the vacuum, and the faint echoes of the Big Bang that ripple across space. It is a lullaby older than time itself, present before galaxies formed, and continuing even as stars die and new ones are born. Every part of the universe participates in this gentle song. Atoms oscillate, photons drift, And even empty space carries a hidden, quiet energy. You are part of this hum. The particles in your body, the air around you, the light in your room, all are woven into this cosmic vibration. Listening to it can be soothing, a reminder that you are never truly alone, that you exist within a living, breathing universe, quietly resonating, endlessly awake, yet soft, serene, and gentle. The eternal hum is a comfort. It whispers softly to the mind and soul, telling us that even in vast emptiness, there's connection, presence, and life. Think of the eternal hum as a lullaby that stretches across billions of years. It began with the first quantum fluctuations, the gentle ripples in the vacuum, the soft energy of the newborn universe. As the universe expanded, stars ignited, galaxies formed, and yet the hum continued, unchanged and serene, linking the very smallest vibrations to the largest cosmic structures. It is everywhere, in the space between galaxies, in the motion of planets around stars, in the oscillation of atoms in your body, and in the faint glow of the cosmic microwave background. This cosmic lullaby reminds us of continuity, of timelessness, and of the gentle persistence of existence. Even when we feel disconnected, even when the night seems quiet and empty, we are immersed in this hum. It connects us to the universe, to all life, to all matter, and to the infinite, unending flow of energy that permeates space and time. Imagine lying in bed, feeling this gentle resonance flowing through you, soothing your thoughts, quieting your mind, and guiding you into peaceful rest. It is the ultimate comfort, knowing that across the vast cosmos, there is a soft, eternal song, and that we are part of it, forever cradled in its gentle vibrations. As our journey comes to a close, let us take a final moment to breathe in the calm, to feel the soft hum of existence surrounding us. The universe continues its eternal rhythm. Even as we drift asleep, galaxies swirl, stars shine, atoms vibrate, and the vacuum pulses gently, all in a delicate, ceaseless dance. You are a part of this dance, moving quietly, breathing softly, and resting within the vast, infinite hum of the cosmos. Tonight, let this knowledge soothe you, that even in stillness, there is motion, even in darkness, there is energy, and even in quiet, there is life. The eternal hum will continue, long after we close our eyes. A gentle, infinite lullaby for the universe, and for us within it. Good night, dear listener. May your dreams float gently on the cosmic waves. May you rest peacefully in the soft embrace of the universe, and may the eternal hum carry you through the night until morning light finds you once again. Goodbye.